London Market Forums, bringing insurance professionals together.
I'm really passionate about the fact that I think robots and automation is a real force for good. And you can see that sort of particularly in the public sector, where we can sort of redeploy resources to frontline services and things using automation. And something that was just mentioned there, and how we can make humans superhuman with AI. We did our Imagine event in March, and we had Gary Kasparov speaking, and he talks about. I mean, he was obviously everyone knows. He was beaten by Big Blue in the about 10, 20 years ago, whatever it was, and by AI. And he says the hardest chess opponent for him to beat is the club chess player with a computer machine next to him, helping him out. So you've got the brute force of the computer with the creativity of the human being. And it led me to sort of think for a moment that actually, could we automate, and I was just thinking this, could we automate the CEO, so the strategy of the organization? Probably not, because referential learning is all about trial and error, and then sort of learning from the experiments, and then improving from there on. And how many companies are going to go through that trial and error in real time, in real life? There'll be a lot of sort of bankruptcies on the way before you get to the real strategy. But what you might find is actually you could augment the CEO with AI and machine learning, and help them with the strategy, and then become that superhuman chess player that's very, very hard to beat. And then also on the point of the robotizing of work, we did some research with Goldsmiths University about making work more human. And again, I think there's a lot of this of taking the robot out of the worker, and making the work much more fulfilling, and reducing attrition rates and things in organizations. And very rarely do I come across automation programs where the agenda is just pure efficiency gains. It tends to be about reducing attrition, making work more human, making deploying people to more value-adding type of work. So if we sort of carry on. So the impact of AI, and I put this sort of slide together to sort of see where it came from. I sort of found the first reference for automation comes from Homer and Greek times. But I think the relevance of this is, why are we talking about this today, and why is it now relevant? First of all, these guys, McCulloch and Pitts, the poet philosopher, came across. They were doing research on brain functions. And they came across this idea of the neuron in the brain, and how it works and how it fires. And then these guys, Rosenblatt, came along a little bit later on and started sort of coding that up in a computerized way, and working out how to make use of that, and starting doing the research of how do we mimic human beings and human intelligence. But it was a sort of single layer. And then Minsky came along and killed everyone's fun. And said mathematically that you can't actually, with a single layer neural network, code up the XOR problem, which is a non-linear function. So you can't actually do non-linear functions with this. So there was what's called the first AI winter. And then Hinton, who then sort of appears, his photograph doesn't change, and he doesn't age over those photographs, but the Hinton's obviously been quite a key character in all this, and they developed multi-level neural networks and a way of back-propagating the error from the output all the way through. So we can now train multi-level neural networks, which means that we can do non-linear problems, and we can start solving big problems. So this is sort of the first big leap that allows us to use neural networks today. But it was hard to scale. And now the key reason why we're talking about this in this room today is the fact that we now have much better computing power, much faster computing power, and we've also developed much more brute force. So we've got large data sets now. So there are image data sets that you can practice this sort of stuff on that's being assembled. So as an individual researcher, you don't need to sort of pull all the data together, because one of the challenges is scale of data and brute force computing power. So we can put all that together and actually train these things up. And so these researchers then came up with something called the convolutional neural network, and through that, they finally got to the breakthrough in 2012 where we could actually do image recognition. And what the big problem they solved in image recognition, so round about this sort of time in the 1990s, I was using neural networks to have a look at images in pig carcasses. We were trying to automate the cutting up of pigs in slaughterhouses, and I was trying to recognize the line of the spine. But the challenge you've got is every image, everything looks slightly different. You've got rotation, scale, and all these sort of things. And with convolutional neural networks, they could finally, in any image of a cat, whether it's a big image or a small image, whichever version, side of the cat you're looking at, they could come up with or codify the concept of catness, and distinguish catness from dogness and other animals. And that was a really important breakthrough, because it now means that you can look at a street scene and you can see the lines, the road markings. You can recognize every single parked car as a parked car. You can recognize every tree as a tree. And you'll see sometimes these images of videos where you've got a little square over the different objects in the image. But because we can now cope with scale, rotation, different angles of different objects, or the same object, or different versions of the same object, and recognize its catness, if you like, we can now do an awful lot of stuff with this, which is very exciting. What's interesting, we have also mentioned physical robots. The automation of factories is way ahead of where we got to with the automation of back office and front office work. But over that time, I liken this to sort of the RPA side of things, the rules-based robotics. And then we got on to OCR with vision systems. And this was a snake robot developed by some people from the research center I was working in many years ago. But we've now got to using this capability of being able to recognize objects to drive driverless cars around. And as such, it's got to the point now with intelligent OCR where we can look at objects on a page, and documents get really complicated. So it's not as exciting as driving a car down the street, or maybe one day we'll get to Formula One with driverless cars doing Formula One and see who beats who. But when you look at documents, they're actually sort of perhaps in some ways even more complicated. You get tables, nested tables, checkboxes, and the like. So using this technology to draw that out and that information is eminently feasible now, and something that we can achieve, which means that it's going to have a really big impact. This study sort of showed that it would be 5 to 7 trillion, which puts it at second place on the economic impact of this technology. And a bit of research by Deloitte. I presented with them last week, and they sort of put this statistic up. And we've already seen that half of work will be automated by 2025. So we've seen that earlier today. But this is why it's real and achievable. Another analyst we're working with, Harvey Spencer in the US, has done an analysis of the different types of documents and the value that we can get out of digitizing this sort of stuff in the US. And you can see about 14 billion worth of economic value we can get from this market. And a lot of you will sort of recognize. I mean, accounts payable is our top use case. Order entry tends to be our second use case. But then you've got healthcare insurance, life insurance. So a lot of stuff in the insurance markets you can automate, including sort of claims processing and things like this. And again, one of the things that people sort of think a lot about in this is sort of the efficiency gains, but it's also about the customer service improvement. Imagine you've got in health insurance, you've got a life event, and in that life event, you've been given some announcement that means you can't work for the next 6 months or 12 months or whatever it is, which is going to be very, very unsettling in itself. Imagine now through improved processing of the data that you can now give an answer to someone within 12 hours, 6 hours, and say, yes, we will pay out your salary for the next 6 months, 12 months. How settling and reassuring that is going to be rather than saying, we'll have a look at it and it'll be sort of 3 months down the road before we can give you an answer. And I was with someone yesterday who was talking about this sort of stuff as well. And they were sort of saying, well, actually, not only do I submit the event and I can get a response back saying my salary is going to be paid, but actually maybe the insurance provider can also say, and here are all the forms, and we'll help you fill them out automatically because we've got the RPA technology to do that, to get all your benefits and things that you're now entitled to as well. So you can get extra income as well. So that lifting of customer service means top-line growth for companies, not just the bottom-line impact that everyone tends to think about with automation. And this just goes sort of the different types of sort of documents and things that we can now go after with automation, the handwriting, lower resolution documents, sort of standard forms, insurance forms, and all that sort of good stuff. So we've talked a little bit sort of more nebulously about the concepts, AI, machine learning, it's all going to save the world. But what does that actually mean in terms of sort of how do you implement this in your organizations and actually make it a little bit real? And I talk about sort of the 4 key skills of intelligent automation. So RPA, robotic process automation, tends to be the rules-based. So actually, let me just pause there. Who's implemented robotic process automation in their organizations? So 1 or 2. So actually, there's probably a need. Who understands what robotic process automation is? Robotic process automation is? It's a smattering in the room. So actually, it's probably useful to sort of try and define this bit to begin with as well. So this is, sometimes I call this integration 3.0. It is the ability to move data. It's like the macro has climbed out of the spreadsheet and got onto the desktop. You can now move data between applications, which means you can use best-of-breed applications and work with the user interface of those applications as well as through APIs, as well as through the database level as well. But chiefly means you can be a lot more agile about the integration and development of business processes and automating existing business processes because you can now work with the desktop in the same way that a human being can work with the desktop. But it's very rules-based. Like a macro, it's a rules-based type of approach. But it therefore means before the AI and machine learning came along, we still needed humans because they have the eyes and the capability to read documents and extract the data from those documents. So now with supervised, sort of unsupervised learning, fuzzy learning, etc., with IQbot in Automation Anywhere, we can now read documents and do very, very well at reading those sort of documents. And so rather than having to put that off into a shared service center somewhere in Manila or wherever it is, we can now do that with automation. Then the other 2 skills are cognitive reasoning. So this is that ability to make a decision. So I'll show you an insurance claims processing process in a moment. But the ability when that claim comes in to be able to say, it's either a very high probability this claim is fraudulent or that it's got a very low probability of that, and then routing the claim accordingly to a specialist team or to the settlement team as a result is an obvious example.